All right, welcome everyone. Thank you so much for joining us. Hopefully you've all received your Uber Eats vouchers, and if you haven't, just contact me and we will sort all of that out straight away for you. Really appreciate on a Friday afternoon at 12 o'clock that you've joined us. I understand that everyone's languishing at the moment across various states in Australia, and our screen time has rapidly increased as the days go on. I don't know what some of your staff are feeling, but I know that the general feeling with us is we're trying to stop Zooms after 4:30 because everyone really needs a bit of a break as we try and be agile with the coping with homeschooling and cooking more and potentially going for a glass of wine a little bit more often than we should. So welcome to our Aruba Trident presentation. Trident have been lucky enough to partner with Aruba for many, many years. We did used to have a number of suppliers with our infrastructure and networking, but we decided that once we started working with Aruba, that they were definitely the company that we wanted to partner with. We really like their agility, the ability to contact executives within Aruba. The account managers and BDMs at Aruba are absolutely terrific. And I know a lot of you will particularly know Sid, who looks after Trident, and he's been with us for many, many years and always finds a really good, innovative solution. And I think that's what our partnership with Aruba has shown over the years, that we can provide some real innovation. It's not a cookie cutter approach with any customer. We try and come up with the right solution. And one of my favourite things about Aruba, of course, is its lifetime warranty. So I'm going to hand you over to the lovely Sid. Like most of us on this panel, we haven't had a haircut for quite a long time. I worked out the other day that I hadn't been to the hairdresser since February 2019. But so enjoy yourself today. Hopefully you're eating something really cool. And I hope that you get something from this presentation. Over to you, Sid.
Thanks, Katie. Well, just to let you know, I did cut my own hair for this conference. So if anyone wants hairdressing tips, I'm open to it today. Well, look, thank you so much for the Trident team for arranging this. We've got a very packed agenda for you guys today. We were lucky enough to get Mark Verbloot, who's the Director of Product and Solution and Engineering for Aruba for the Asia Pacific. So thank you, Mark, for helping us today with this presentation. And we've got Darren Smith, who is the Aruba Category Manager for Australia and New Zealand, who's going to cover off what's the latest and greatest in switching, new innovative aspects, new products that have been added to our range. So Darren will cover that off. So we're going to start off with Mark Verbloot, who is going to cover off a topic that I get lots of people asking me about, which is Wi-Fi 6E. So Mark's going to cover off what is Wi-Fi 6E and what is the Aruba solutions to Wi-Fi 6E and new products that we're releasing. So Mark, over to you. Thanks.
Well, thank you, Sid. And hi, everybody. It's good to be here. And we're also talking about haircuts. Mine looks okay. I let my wife cut my hair about 2 weeks ago. She did a pretty good job. I was very skeptical, but I was happy to say that it looked okay. So that's what we're doing, in this crazy time we all find ourselves in. So thanks for having me today. I'm going to be speaking about Wi-Fi 6E. I want to just start off the presentation by taking us back a little bit in time, just to give some perspective on the evolution of wireless technology. Wireless technology has been with us for almost 20 years now, and sometimes we forget that is still a relatively new technology, and it has evolved and developed very, very quickly. So I've got a bit of a timeline here on the screen. Some of you may remember that in early 2000s, we first saw the introduction of an integrated Wi-Fi chip inside the computer circuit boards called Intel Centrino. That's what really started it all. At that point in time, it was very limited technology, really based for convenience. What really changed the world was the introduction of the smartphone, the iPhone in 2007. That seems like a lifetime ago, but it wasn't that long ago. We didn't have iPhones. And in conjunction with that, we saw the Wi-Fi standards evolve. And one of the big changes occurred in 2009 with 11N. And specifically 11N was when we started to see Wi-Fi come into education in a much more substantial way, because at this point in time, we started to see schools introduce laptops or netbooks, and they began to embrace digital learning. And this was in particularly spurred, if you remember, in 2009, during the GFC, we had the digital education revolution spurred by the federal government that gave a lot of funding to schools to invest in wireless. 2010, we saw the tablet come out, the iPad, and that again found its way very quickly into education. Now, going back to the standards again, it was 4 years between 11N, which we now call Wi-Fi 4, by the way, and 11AC, we now call Wi-Fi 5. This standard introduced in 2013 was quite revolutionary in that it significantly increased the ability and capacity of our network. So when you look at the 11N technology, it made possible one device per student that you could get some reasonable throughput with. 11AC was really all about increasing the throughput and between 3 to 4 times. So many of our customers were upgrading from 11N to 11AC. They saw significant improvements in their throughput, the ability to have multiple devices per student. And then more recently, it's about 3 years ago now almost, we introduced Wi-Fi 6. So Wi-Fi 6, 11AX, it's also known. This was not so much about increasing aggregate throughput, but more about increasing efficiency. And I'll talk more about that in a moment. At the same time, we started to see a lot of STEM devices come online, a lot of IoT embraced as part of the learning regime. And 11AX is a good technology for that. And today we find ourselves with a new technology standard being introduced called Wi-Fi 6E. And this is all about opening up additional spectrum in the 6 gigahertz band to give Wi-Fi much needed additional capacity. So let's go into that in a bit more detail, right? So I like this slide here because this is a slide, this is from our labs taken in 2009. And what we're showing here is we actually are stress testing how much throughput we can get in each of these devices through a single access point. Now, on up here on the stand, it's one of the old 11, the AP125s, the old Aruba 11N AP, which was heavily used in schools throughout New South Wales and still is actually deployed. And they had set us a benchmark of the 30 laptop test. And one of the criteria we have to pass to deploy in the schools was we had to provide sustained 2 megabits per second bidirectional throughput per laptop, right? 2 megabits, which today you'd laugh at, not being such a low requirement. But at the time, it was really hard to meet this requirement to actually deliver 2 megabits up and down on 30 laptops at the same time. Took a lot of engineering work and tweaking of the solution to make it work at the time. We've come a long way since then. When we look at the classroom today, well, you know, you've got students with all kinds of devices, typically 2 to 3 to 4 devices, their smartphone, their tablet, their laptop, Chromebook, whatever it is. And so our networks have had to scale accordingly to take into account the way we were trying to deliver learning digitally. So let me take a few moments to try and fundamentally go through the developments between Wi-Fi 5 and Wi-Fi 6. Now, this slide tries to illustrate a fundamental challenge we've had with everything up until and including Wi-Fi 5. And that is that the technology of wireless is a contention-based technology, and it is multiple devices competing for a single access or single channel. So being contention-based, what this slide illustrates is that if I've got 6 users trying to use Wi-Fi, only one at any one time actually has access to the channel and is sending and receiving. The other 5 are waiting. And this is illustrated very, very clearly when you start to get lots of users on a single access point and things begin to slow down and people get pretty frustrated. And that's because everybody is contending for a single channel resource. And often that contention leads to collisions and back off and retransmissions. And the net result is a number of unhappy users. Now, because we have quite good speeds with Wi-Fi 5, Often this is not really noticed in practical terms, but that's what's happening in the background. So when you load the networks up with more devices, contention increases, and ultimately everything slows down. As we move to Wi-Fi 6, Wi-Fi 6 introduced a really good technology called multi-user MIMO, also uplink and downlink. And what this means that if all these devices are Wi-Fi 6 devices and they're all able to access the channel at the same time, because what Wi-Fi 6 does, it actually breaks the channel up. Instead of being a single big resource that only one device can access at one time, it's broken up into resource units, and each device can access a fixed number of resource units at the same time. And we see in a Wi-Fi 6 deployment implementing uplink, downlink, multi-user MIMO, that in some cases up to 13 devices can simultaneously have access to the channel and transmit. Now, each individual device, right, transmits at a slightly slower rate than a single device, but the net result is better efficiency. So as I mentioned before, right, Wi-Fi 6 is all about improving efficiency. Wi-Fi 5 was about improving throughput. That's the key difference as to why it happens. So, and another way to look at this is to show the difference between Wi-Fi 5 and Wi-Fi 6. And I like this slide because it illustrates it really well. Let's take the example of an intersection. In an intersection, if you have no traffic lights, well, this is the result. The left-hand side, it's a bit of a mess. It's congestion. It's a huge traffic jam. There's no order, and everything gets really, really, really slow. That's because we have uncoordinated access, contention-based, and ultimately, this is a great illustration of what happens when you have too many devices on a single AP running Wi-Fi 5 or lower. In Wi-Fi 6, the concept of uplink resource allocation, effectively, you can think of it as being like a traffic light system, where rather than every device trying to contend for the same time and resulting in a huge traffic jam, I'm scheduling access to the channel, and I'm scheduling access in lanes, okay? So on the left-hand side, no one's using lanes. Everyone's just going for it, and it's causing a big mess. On the right-hand side, you can see here we've got lanes, we've got cars in lanes, and we've got those cars waiting in their lane for their the traffic light to give them permission to go. And that really is a good illustration of how Wi-Fi 6 works, with the resource units being equivalent to the lanes, with the scheduling being equivalent to the traffic light. You can see that I can have lots of users at the same time in their individual lanes, accessing the channel and working very nicely. So the net of this is that schools, customers that have deployed Wi-Fi 6, and now Wi-Fi 6 devices are very, very common. They're going to see significant benefits in contention, less transmission, and overall better user experience with Wi-Fi 6. Okay, let's now talk about Wi-Fi 6E. So before I dive into it, I'm going to play a short video which kind of covers the key points quite nicely.
Insatiable demand, exponential growth in IoT data, latency-sensitive voice and video. Wi-Fi is under ever-increasing pressure to deliver the wireless experience we all expect. Wi-Fi 6 is a leap forward, offering greater efficiency, higher throughput, and maximum levels of security to address these bandwidth challenges. Wi-Fi 6 means multi-user traffic management so you can simultaneously connect more client devices, battery-saving techniques so you can get more life out of every device before recharging, and secure guest access so you can feel secure no matter where you're working. Despite this, modern Wi-Fi networks are still only delivering a fraction of their potential. The airwaves are simply too crowded. The world is increasingly wireless, yet demand far outstrips supply. That's why the release of Wi-Fi 6E is so significant. It extends the same Wi-Fi 6 capabilities to the 6 GHz band. This translates into more than double today's system capacity, with more adjacent spectrum to meet growing business demands, wider channels to deliver on the promise of 160 MHz, and zero interference from electronic devices like wireless speakers, power cables, or cordless phones. With the 6E band already in use, Regulators have designated 3 device types with their own rules to make it possible to better share the band with Wi-Fi. And you can better support new use cases like virtual reality and 8K video with multi-gigabit connections and increased capacity. At Aruba, we've got you covered. Our wireless expertise and track record will help you successfully deploy Wi-Fi 6 today and plan for the Wi-Fi 6E world of tomorrow. To learn more, visit arubanetworks.com/6E.
Okay, so that was a great short video that summarizes the key benefits of 6 and 6E. So let's talk a bit more about Wi-Fi 6E. So some of the key points mentioned on that short video that you see summarized here. First of all, the 6 gigahertz band is a brand new pocket of spectrum that is not really used for anything at the moment. So we call it clean spectrum. And it's pretty exciting because being clean, there's going to be no interference sources like we experienced with particularly 2.4 gigahertz and more increasingly on 5 gigahertz. So clean spectrum, a lot of spectrum means that we can have some fantastic performance. Secondly, Wi-Fi 6E will only work with the new WPA3 security standard. So it's going to be inherently more secure than running Wi-Fi 6 or 5. There'll be no option but to use WPA3, which means all devices that support Wi-Fi 6E will be inherently more secure than the current generation of devices. Being higher capacity, there'll be lower latency, so it's going to be great for latency-sensitive applications. And we mentioned about the channels. What we mean by super wide channels is at the moment with Wi-Fi 5 and Wi-Fi 6, we typically deploy a maximum channel width of 80 megahertz, so that's a pretty wide channel. But Wi-Fi 6E will let us go beyond that because there's so much increased spectrum. So what we want to talk about here is a bit more about the channel capacity. What you see on the left-hand side is that because of the congestion and the limited number of channels we have with Wi-Fi 5 and Wi-Fi 6, typically what happens is we tend to deploy in the smaller channel width. So most of our high-density deployments in schools will be 20 megahertz or in most cases 40 megahertz. And this simply limits the maximum speed you can get per channel because the width is a little bit smaller. There aren't many deployments. We see here 9% roughly that are using the full width of channels 80 meg, and that's because there aren't enough channels in the 80 megahertz if they're deployed if they're configured 80 megahertz to give us good throughput without channel reuse issues. And at the same time, we're seeing explosive device, right, in explosive growth in devices. There's lots of stats about the number of IoT devices out there and so on, but it's in the billions. And in particular, what happens is in congested areas when there's lots of Wi-Fi being used, there's a lot of co-channel and adjacent interference, and that limits also the channel widths and the availability of spectrum. So these are kind of the current challenges that we're seeing in the current spectrum. When we look at 6 gigahertz, this is a great slide because what it illustrates quite nicely, right, the increased capacity between 5 gigahertz and 6 gigahertz. And this relates to the number of additional channels that are available here. And if you add, if you kind of do the sums here, you get up to 3 times the capacity of the 5 gigahertz band. And what this slide shows is these small bars are 20 megahertz channels. These larger ones are 40, these are 80, and these are 160. So straight away, you can see that I can easily deploy many more 80 megahertz channels. And I can even deploy 160 megahertz channels if I really want to. There's enough capacity if I implement the full 6 gigahertz band, right? So this actually is 120 megahertz of spectrum in this whole bandwidth, whole width here. And if I implement all of that, then I've got effectively 3x the additional capacity of Wi-Fi 5. In addition to that, this is clean spectrum. So what I'm going to be able to do is if I deploy Wi-Fi 6E, I'm going to be able to say, I want my 6E generation devices only to use 6 gigahertz, everything else on 5 gigahertz, and I can then segment my applications based on these super wide bandwidth that's available. What's happening around the world is that the regulators are opening up 6 gigahertz, and depending on where you are in the world, they have up to 1200 megahertz of capacity to open up. So let's talk about Australia specifically. At the moment, we're in discussion with ACMA. ACMA has a discussion paper open about opening up the 60 gigahertz band. At this point in time, 6 gigahertz is not open for public use. And what we're saying here is that we want 6 gigahertz to be unlicensed spectrum for anyone to use. Just like we have 2.4 gigahertz being unlicensed, parts of 5 gigahertz being unlicensed, and all the Wi-Fi vendors use that spectrum to communicate with Wi-Fi. We want ACMA to open up the full 1200 megahertz in the Wi-Fi, in the 60 gigahertz band for Wi-Fi 6E. And Aruba is involved in representing the industry to ACMA, as we are with other countries around the region, to advocate for that. At the moment, ACMA is looking at this. They're considering it. They initially were only considering opening up 500 megahertz of that. So depending on that, they want to sell the balance as licensed spectrum, but we believe that's the wrong move and will disadvantage Australia and our economy in the future if they don't have the full spectrum available. So we're working with them to get that. No decision has been made yet, but if all goes to plan and they open up the full 1200 megahertz of spectrum, then we're going to get 3 times the capacity available. And you can see here that by comparison, when you look at the capacity in the 5 gigahertz bands, it's only a fraction of what's available in a 6 gigahertz band, which is why it's exciting for the industry. So in terms of the global presence of 6 gigahertz, yes, it's been fully decided in the US and some parts of Europe. In APJ, in Australia, particularly in Australia, we're still not quite there, as I mentioned before. In our region, South Korea is the first Asia-Pacific country to open up 6 gigahertz. And you may be not surprised to learn as a result of that the next generation Samsung devices, the Galaxy, I think it's the S21, it's coming out with 6E built in. And in fact, we're testing that with Samsung. They've got early access to our 6E product in Korea, and we're very happy to be working with them testing 6E functionality for these new devices. But we expect to see 6E devices appear very rapidly in 2022. Now, I just wanted to highlight on this slide that we do expect the ramp to be pretty fast for 6E. Now, if you go back a few years when 6 just came out, it was a similar situation when we saw very, very quickly that the phone vendors supported Wi-Fi 6, the tablet vendors, the laptop vendors were very fast. And today, pretty much every device you buy supports Wi-Fi 6. Unless it's an extremely low cost device, which may only support 2.4 gigahertz or only support Wi-Fi 5. But by and large, the cost of the silicon has come down, that it's a pretty standard inclusion in most devices, particularly in the ones that are used in education. We expect the same thing to happen with Wi-Fi 6E. The forecasts are for around about 338 million devices will ship just this year and 1.5 billion by 2024. So we expect this to be a rapid uptake. And as I've outlined, some of the key benefits of Wi-Fi 6E are such that we believe it's going to be very popular. In particular, in areas where you want to segment off your applications. So you want ultra high bandwidth applications to run in the 6 gigahertz band. They can coexist with the existing 5 gigahertz applications and 2.4 gigahertz users. In fact, the APs are going to be tri-band access points. So they'll have a 6 gigahertz radio, a 5 gigahertz radio, and 2.4 gigahertz radio. So they'll all run simultaneously. So some of the devices we feel that are going to be 6 gigahertz capable. Already we are seeing some of the Samsung devices I mentioned before, a series of laptops, a series of phones, some desktops already supporting it, some Dell devices, excuse me, and various chipsets from the Wi-Fi manufacturers. Now, interestingly enough, the iPhone 13 was released a few days ago. If I'm not mistaken, and correct me if I'm wrong, it doesn't support Wi-Fi 6E. I haven't had a chance to check closely, but I'm told it doesn't, which was a bit surprising. So I guess we'll have to wait for the next one, but that'll happen probably pretty quickly as well. All right, so this is often a good discussion point about this discussion around 5G and Wi-Fi. Often we hear whenever there's a new release of wireless technology or LTE technology that, hey, 4G's come out now, it's the end of Wi-Fi. Why would I need to use Wi-Fi when 4G is everywhere? Well, history has shown us that it wasn't the case. In fact, Wi-Fi usage increased when 4G came out, as it did with other technologies. And in the case of 5G, it's similar, right? What we're seeing here is that a ratio of the actual mobile traffic versus the offload traffic, because in the case of 4G and the case of 5G, it really is not economical to deploy 5G base stations everywhere, particularly indoors where you want to have access to fast technology. So you really can't replace all of your Wi-Fi 6 connections with 5G for two reasons. One, most devices don't come built in with embedded 5G, and there's a cost associated with that. And two, the infrastructure cost of the telco simply doesn't make sense to deploy 5G small cells everywhere. So what happens is that Wi-Fi gets used as an offload technology, and what we're seeing with every release of LTE, more and more Wi-Fi offload, and that's been the case with with 4G and with 5G, and we don't see that really changing. In fact, 6E makes it even more economical for the telcos to deploy Wi-Fi 6E access widely and broadly and have that as an on-ramp. In particular, by the way, the 5G technology is what we call a radio agnostic network, RAN, which means that it doesn't really care how devices get onto the 5G backbone. It can be via LTE 5G, or it can be by Wi-Fi. So we're doing a lot of work globally with the telcos with something called Passpoint as a mechanism to allow any device to connect via Wi-Fi to a Wi-Fi hotspot supporting Wi-Fi 5 or Wi-Fi 6 or Wi-Fi 6E, authenticate using the telco SIM, and directly access the 5G backbone, and then to have conversations with other devices on the network. So just to reiterate then that 5G does not mean the end of Wi-Fi. More so, in fact, it's the opposite. It will proliferate Wi-Fi even more because of the cost efficiencies. And finally, if you go into it in more detail, Wi-Fi is the cheapest technology that is related to cost per megabit, right? So I can transmit the most information over Wi-Fi with the least cost. And so therefore, Wi-Fi has a very strong future. And by the way, we're already talking about Wi-Fi 7. It's about another 3 years away, which will take us to such speeds. We're talking 10 gigabit speeds potentially with Wi-Fi 7. So Wi-Fi's future, I think, is very strong. Okay, let's now talk about our new Wi-Fi 6E solution. We introduced the first 600 series access point a few months ago. It is available in areas where Wi-Fi 6E has been certified by the local regulatory agencies. And we're hopeful that it'll be available very soon in Australia. Now, let's go through some of the key functions of this new features of this new access point. First of all, I mentioned it's a tri-radio. So it has a 2.4 gigahertz radio, a 5 gigahertz radio, and a 6 gigahertz radio. And all those radios operate simultaneously. So you can see very easily here that how you can get this huge increase in capacity by having a tri-radio access point. We have multi-gigabit ports on this. So they're smart rate ports operating 2.5 gigahertz, up to 2.5 gigabits per second. And you can support very high client densities, up to 512 clients per radio, right? Remember, there's 3 radios in this access point. So you can support very high densities when you spread your clients across 5 gig and 6 gig. Huge throughputs we can see here. We can run these very wide channels, right? Remember I mentioned you've got this 160 megahertz ultra wide channels. And if you have the full spectrum available, you can run up to 6 of these channels. So think about the capacities we have available. We truly are going to get well beyond the gigabit on the network of actual device good put, right? Actual data throughput with Wi-Fi 6E. So for the first time, you're going to have more than a gigabit between your access point and your switches to utilize the full benefit of Wi-Fi 6E. And in fact, it'll be multi-gigabit. We've done a lot of testing already, of course, with this, and we are seeing more than 2 gigabits per second sustained of actual data throughput when using 3 radios or even just 2 radios on these new generation access points. And there's going to be some fantastic use cases. 4K video now is pretty common. 8K is coming out. This will be a great use case for Wi-Fi 6E. In addition to that, we have the other great features incorporating with the existing 500 series APs, such as the integrated IoT platform. Remember, all of the new generation access points have a built-in Zigbee functionality, a built-in Bluetooth functionality. These can be used to directly connect IoT devices. And we have a very strong ecosystem of IoT partners that integrate directly into the access points. So that's a good value add. And one last thing I'll say about this is that even though we may not have 6 gigahertz regulated and enabled by ACMA today, it doesn't mean you can't deploy this access point as a Wi-Fi 6 AP with 6 gigahertz radio turned off. That's completely a supported configuration, and via software upgrade, as soon as the regulation is enabled in Australia, we can turn on 6 gigahertz radio and start running that. And one last point I often get asked is that, what about my design? How do I design for 6 gigahertz? Do I need to change my AP density ratio or my AP coverage ratio? And the answer is no. The propagation between 6 gigahertz and 5 gigahertz is very, very similar. Cell sizes are very, very similar. And our guidance is that keep the same design parameters you do today, and no need to change that to deploy 6 gigahertz. So if there's any concerns around there, just continue with your current design methodology using for Wi-Fi 6. All right. So I just want to finish off with a couple of forward-looking applications for 6E. So what do we think's coming, right? I think one of the big applications we'll see is AR, VR. Now, a lot of schools are already using VR. It's a great learning tool. There's some pretty good software out now available to really enhance the learning experience. One of the biggest problems with it is that you've got this horrible cable on the back of your headset. So you're tethered to a fast desktop. And that's predominantly because of the uplink speeds required. We certainly are hearing that Wi-Fi 6E will be, I guess, the technology that cuts this cord and makes the whole VR experience much more flexible and immersive, being able to move around freely. 8K ultra high streaming applications. Another good one is tethering. If you think about the speeds of 5G, often the limitation is how fast we tether our devices. If we can tether our devices through 6E, this will mean we can fully utilize 5G and the multi-hundred megabit throughput you get with that. And also, as we move to the generation of electric cars, the connected vehicles that are coming out, we're going to see, I think, a lot more cars, newer cars, being built in with both Wi-Fi 6 and 6E embedded for integrated entertainment and telemetry. That's just a few applications we see coming. I think it's very exciting times. And so with that, I'll conclude my presentation and I'll pass the stage back to Darren.
I think it's to me for the moment.
Back to you.
Yeah, so we have a few questions, Mark. So I guess what do you see the evolution of devices? What do you think the time frame will be for more and more devices to be available, especially in the laptops? What do you forward looking?
Yeah, I covered some of that on some of the later slides. I'm not sure when the question was asked, but we already have a number of devices out today that support 6E. So Samsung appears to be the leader in this. They've got a range of tablets, phones, laptops already supporting 6E. I also mentioned that we are, in fact, Samsung globally uses Aruba in all of their R&D facilities as well as their offices. And we have a partnership with them, and they already are an early consumer of our AP635, the 6E access point. So yeah, I think we'll see a lot of devices pop out in 2022.
All right. Someone's asked about the new AP that's coming out 6E, and I think you've addressed it. is it backward compatible if we go 6E? Is it, when the 6E is enabled, when the 6 gig is enabled, is it backward compatible? Will the AP be backward compatible?
Yeah, so I did cover that again. So I mentioned the APs are tri-radio, so they contain a 2.4 gig, a 5 gig, and a 6 gig radio. The 6 gig radio is only used for 6E. That's its sole function. And if you recall, I mentioned that it is clean spectrum. So right now, nothing really is using 6 gigahertz. So there's no interference. So what you can do, and I think a lot of customers will probably deploy it this way, they will dedicate the 6 gigahertz radio only for 6E devices. Now, remember, if you go and buy a Samsung S21 that supports 6E, that also supports 6 and 5 and 4. So that device can connect on any Wi-Fi technology that's out there, but you want it to connect on 6E to maximize its potential, right? So we can configure it in a way where we can effectively preference 6 gigahertz for all 6 gigahertz capable devices, and everything else connects on the existing 5 gig and 2.4 gigahertz bands. So that's how we can leverage the power of 6 gigahertz very, very effectively with new generation devices and access points.
Thanks, Mark. I think we've addressed most of the other questions. I guess, when do you see, what time frame do you see from an Aruba perspective, ACMA approving the spectrum to be opened? Yeah, look, we don't know for sure. We are very hopeful towards the end of the year or early next year it'll be approved. We're actively lobbying ACMA, or lobbying, I guess, or we're advocating for the full 120 megahertz to be open. So in the Aruba CTO office, we have a number of industry leading specification and standards people that are heavily involved in the Wi-Fi 6E standard and 6 standards, and they're also heavily involved with all the international regulators about making the case to open up 6 gigahertz. Now, they did a great job in the US opening up 6 gigahertz very, very quickly. They're also working in our region, particularly with ACMA, making the case for them to open up 6 gigahertz to full 120 megahertz of that 6 gigahertz band to give us the full capacity. So we're hopeful that decision will be made, fairly soon on that. Oh, thanks, Mark. All right, I think we've addressed all the other questions. I think there's Alex is putting out a poll question very soon, but in the meantime, so feel free to answer the poll question. I'm sure Martin will give away for the winner of the poll question. So before we go any further, we'll give everyone a little bit of time, a couple of seconds before we move on. So, all right. So Darren, I'll hand over to you. Darren is our category manager, and he's going to cover off the latest and greatest in switching.
Thanks, Sid, and welcome everybody. So just wanted to cover today some of our newest switching announcements we've had over the last, or maybe just under the last 12 months. So there's been lots of new products coming out in this space. So I'm going to run through some of them today. But just to set the scene, you may be aware a couple of years ago now, we launched our CX range of switches, and they brought a lot of benefits to our customers that didn't exist in either our products or even products from other vendors today. Now, some of the really cool things about CX up on the slide there, but some of the key ones, it's about having this unified operating system from the edge of your network all the way through to your sort of core and data center. We can manage these switches via our Aruba Central Cloud Management Platform, which is gaining a lot of popularity at the moment. But some of the real good things around our CX switches are some of the advanced analytics and features that are actually built into these products. And I'll go into a bit of detail about that in a moment. So when we're looking at our CX switches today, so the vast majority of these products, with the exception of some of the real low-end ones, have what we call a network analytics engine actually built into the switch. Now, you might think, why is this important? Now, the real benefit for you guys as sort of network managers and network administrators is actually helping you get to the root cause of problems a lot quicker. So if we look at the left there, if you had some problems on your network, it can actually be quite tricky to actually get to the bottom of what that problem is. So you might have to run various debugging commands or show commands or anything else like that on the switch. You need to try and get data out of that switch to actually see what the problem is. And you may end up using sort of third-party tools and things like that. So what it actually means is when you have a problem on your network, it can take you quite a while to actually get to the bottom of it. What we're actually doing with CX is actually taking some of this data on the switch itself. So it's like having, one of our customers said this, and it's on the slide there, it's like having a 24/7 network technician built into every single switch. So it can actually look at things that are happening on the switch and start reporting straight away. So if it's things like ports going up and down or any other problems like that, it can actually notify you there's a potential issue. Now, moving forward to the actual switches themselves, as I mentioned earlier, the benefit of CX is this one single portfolio to go from the edge of your network all the way through to the core and then the data center. Now, if you compare what we do with our switches against some of the other vendors out there, they may potentially have 3 different architectures. So if you wanted a cloud managed solution, that could be one architecture from a vendor. Your larger campuses could be a completely different architecture. And then the data center, a different one again, each with different management tools and operating systems that you need to learn. So the benefits around CX is it's that one architecture. So whether it's a very, very small site that you've got with just like a single switch, all the way through to your data center, it's one operating system that you need to learn and one set of management tools. So it means it's a really efficient way to actually run your network. And one of the other key points on the slide there, there's no software licensing for our CX switches. So if you buy a switch today and it is capable of a certain feature or technology, then you can use that technology. You don't need to pay to unlock any additional features. I always give a great analogy. If you think of our switches like a car, with some of our rivals switches, if you was to buy a rivals car, you would have to buy additional licenses to do things like, I don't know, use the boot, use the passenger seat, or even go above a certain speed. Now, if a car manufacturer actually introduced that, everyone would think they're absolutely crazy, but that's exactly what some of our competitors do today. With the Aruba solution, it doesn't matter. Whatever the product is capable of, you can actually use that technology without purchasing any additional licenses. So looking at the portfolio of products here, now there's probably a couple of new things on this slide that you may not have seen before, but starting off on the left-hand side, we're sort of going from the switches with the least sort of functionality and the lowest cost, all the way up to the top right where we get through to our data center. So a couple of new products on here, the Aruba CX 6000 series, which I'll cover in a moment. They're actually a new switch, which we've announced very recently and will be available to order in the next couple of months. We've then got the 6100 series. So both the 6000 and 6100 are really the layer 2 sort of low feature, low cost edge switches for your network. Then we get through to some of the more popular switches. So the 62 and the 6300 series, that's really what we see deployed as edge switches, certainly in the school environments. So these will give you a lot of abilities around things like PoE, smart rate capabilities on the 6300, and other features like that you'll need. And then as we move further up, we've then got the 6400 series, which is the first chassis-based CX switch, really popular for sort of high density access switches, or quite often as the core switch in a lot of schools. And then lastly, we move up to the data center space where we have our 8300 series switches, which are 1IU stackable switches. And then we have the 8400 series, which is a chassis based switch as well. In the 8300 series, there has been some new products there, which I'll go into a bit of detail about in a moment. And then lastly, we have just introduced this month a new product called the 4100 series. Now, the 4100 series is very similar to the 6100 series in features, except it's a ruggedized switch. And I'll go into a bit more details about what that means in a moment. Now, some of the benefits of these Aruba switches are they contain what we call our latest Aruba ASIC, which is now up to its 7th generation. Now, we're one of only very few vendors that actually make our own ASICs that running our switches instead of using sort of generic ASICs from the likes of Broadcom or Marvell. So what this means is because we actually control the main chip inside this switch, there's really tight integration between the software and the hardware capabilities. So what that means is we can introduce new features very, very quickly on these products. And we've actually done this a number of times over the years. If we were using a generic ASIC from the likes of Broadcom, we're really tied to what we can actually do with that chip, and it will be the same as every other vendor. So this is a real unique sort of advantage that customers can have by using our CX switches. So looking at some of these new switches, I mentioned just now, the 4100 series is a new ruggedized switch. We've actually had some interest already in the education space for this switch, where you might have like a demountable classroom or something else like that you really need to put some networking in quickly. There might not be any room inside the classroom itself to have a rack. So you could potentially mount these switches sort of in a rack outside, as long as it's not subject to rain and things like that. But you'll see there, the idea behind this switch is some of these ruggedized temperatures. So it can support up to 70 degrees. The minus 40 is probably not too relevant to us here in Australia, but up to 70 degrees. So these are designed to be sort of fanless products to operate in these higher environments. They do support 30 watts PoE, and each switch has 4 ports of 60 watts PoE as well. And they will be supported in our sort of Aruba Central and Airwave management tools. Now, these run the same CX operating system, and they do have a couple of different power supplies available as well, both AC and DC power. So if you do have a requirement for ruggedized switching, there's now a CX switch that can actually work in your environment. Moving over to some other new products, the 6000 series switches were announced recently as well, and these will be available to order in the next few months. These are a really low cost CX switch. As you can see, there's going to be 5 different switches in this family, a 12 port switch, which is PoE, 2 24 port switches and 2 48 port switches, both PoE and non-PoE versions. Now, these are fixed configuration switches with 1 gig uplinks. So no 10 gig available on these. There's no redundant power supplies, and you can't plug in a 10 gig module or anything else like that. But they're designed to be a really low cost switch and a great introduction to the CX family. Software wise, very similar to what you get on the 6100 series switches today. Talking of the 6100s, these were probably the last switches that we introduced into this range. So these are layer 2 switches designed for the sort of low cost edge. The only difference between these and the 6000 series is the 6100 series has 10 gigabit uplinks instead of the 1 gig ones on the 6000. So again, if you're looking for a low cost switch, this is certainly a great solution. When we look at the rest of the CX family though, this table here, when you're looking at access switches, just spells out a couple of the differences. And there's just a few things I'll draw on to really sort of help you decide what switches you'll need to deploy. So as we start on the left here, you'll see the 6000 series. When we move up to the 6100, the real difference is the 10 gigabit Ethernet port. So you've got an option then for 10 gig uplink. So if 10 gig is something you want, then it's definitely going to be a 6100 series switch. Moving up again to the 6200, the major differences here, you'll see there's a couple. The first one is the amount of PoE available. So we've now got 740 watts of PoE power available in the 6200 compared to 370 watts in the 6100. So if you've got a lot of PoE devices, that may then make you move to something like the 6200. You'll see a couple of other new things as well here that are supported. So the 6200 is the first switch we have which supports our stacking technology, so VSF. So you can have 8 switches in a stack. And you'll also see it supports a feature called Always On PoE and Quick PoE, and also our dynamic segmentation feature. Now, the good thing about Always On PoE and Quick PoE, let's imagine you've got a stack of switches and you're doing a software update, and you need to reboot the switch for some reason. Usually what would happen, the switch reboots, there's all power is dropped, so all your access points and any other devices that are powered via PoE are actually powered down. And it's not until the switch actually fully boots up again that power is applied. Now, the benefits of Always On PoE is we actually keep that power turned on even during a reboot. So while your access points and other PoE devices might lose network connectivity, they don't have to reboot themselves. So as soon as that switch is up and running and forwarding traffic again, whatever that PoE device is, like an access point, will just start transmitting data. So a great way to sort of increase that uptime of your network. As we move across, the 6300F series, they're now the first switches in our range that support 25 and 50 gig uplinks. So something new there. That isn't supported in any of the other switches today. So if you need higher than 10 gig uplinks, then the 6300F would be your switch of choice. And it also does support BGP EVPN as well. And then lastly, on the edge of the network, we have the 6300M. So the M here stands for modular. Now, what that means is this switch does have modular uplinks and also has multiple power supplies as well. So if you want power supply redundancy, the 6300M is the first switch here that will actually support that. The other features that the 6300M supports is what we call smart rate. As you heard Mark talk about earlier with some of our new access points, as we're getting more and more data coming out of the access points, having a 1 gig link into that AP or even 2 1 gig links might not be enough. So smart rate is the ability to have up to 5 gig connected to our access points, just over your standard sort of Cat5e, Cat6 cabling. So if you're looking for smart rate, then the 6300M would be the first switch that actually supports that technology. And you'd also see there it's got higher power PoE, so up to 60 watts per port as well, which there might be certain PoE devices out there that require. So as you can see, there's various features here, and each switch has a place. So depending on what your requirements are, there'll be a switch to actually meet your needs. Now, moving on to the data center space, we within the last 12 months, we brought out a new switch here, the 8360 series. So this is designed to be that really high performance core switch for a small network, or actually in your data center as sort of a top of rack switch or a leaf and spine switch if you have that sort of technology deployed. So I won't go into all of the features here, but just want to let you know there's a new range of switches here that are available. There's 5 different models that are available. So there's a 12-port 40/100 gig switch. There's then a 32-port and a 16-port 25 gig switch that either have 2 or 4 40/100 gig uplinks. And then there's a 24-port and a 48-port 10G base T switch. And again, they either have 2 or 4 40/100 gig uplinks as well. So a lot of flexibility there to deploy whatever technology you need inside your data center. So when you're looking at our data center range, you might say, well, what switch should I deploy? So this is where to sort of position them products. If you're looking for top of rack switches or leaf switches, you've got options of either 8320s, 8325s if you require sort of 10 and 25 gig, or the 8360 series as well, which will give you them higher speed uplinks. We've then got a range of 40 and 100 gig switches that you might use as your spine switches. And then when we get to the modular switches, you've got choices there of either the 6400 series chassis or the 8400 series chassis. And then lastly, if you're looking for out-of-band management for things like ILO, management of your servers, then we do have a 6300M range there as well that does support different power options. Now, you might be wondering, why would you use an 8300 series in a data center and not something like a 6200 series? It's really to do with the features on the switch, the size of things like the routing tables and the MAC address tables, but also to do with the airflow. So all of our 8300 series switches have been designed to have either front to back or back to front airflow, which is what you'd need in your data centers. Products like the 6200s and 6300Fs do not support that. The only exception is that 6300M there for out-of-band management. So why CX? As I mentioned earlier, compared to other vendors out there, it's a single operating system. So it's only one thing you need to learn across your entire environment. We have this analytics built into every switch, so you can actually get to the root of problems a lot quicker. We have our latest ASICs running in these switches as well. And then lastly, there's none of these licensing costs that the other vendors will have. So just a couple of points there to consider when you're looking at replacing your switching platforms. Now, you might be wondering, well, I've already got some Aruba switches today, like the older AOS series switches, like 2930Fs, 5400Rs. What about them? So just wanted to let you know what's happening on that space. We have end of sale some of them products already. So the 2530G and the 2540 products have already been announced end of sale. They were unique products in our portfolio. So they were the only switches that we had that didn't support or didn't have our Aruba ASIC inside them. And the reason we had to end of sale them switches is the vendor that makes the ASIC has actually end of sale that ASIC. So we were left without a choice. But all the rest of the products, so the 2930s, 3810Ms and 5400s all use our own ASIC today. And at this stage, there is no plans to actually end of sale them switches. Basically, as long as customers want to buy them, the plan is we'll still keep selling them. Now, when we do announce an end of sale, we will support the switches for 5 years after that end of sale date. Plus the switches will also have a lifetime warranty. But just to be aware, all of our new development and all future development is taking place on CX. So if you're looking for some really cool features or new developments, they're all going to be on CX. So that's the thing to be aware of. So if you are planning a switch refresh, definitely be planning to use CX for that. Now, just one other thing to finish up on, not relating to switching at all, but we've got a promotion that's still running until the end of October for some of our user experience insight or UXI sensors. So if you're interested in these, reach out to your account manager. The promotion for these is you basically get the hardware for $1 or for free when you buy a 3 or 5 year subscription. So very, very limited offer until the end of October. And it will run out when we've actually run out of stock of these F-series sensors. So if that's something you're interested in, please reach out to your Aruba rep. And that's everything I had. So has anyone, any other questions that we haven't answered?
I think we've answered everything. Aria's been busily answering the chat. It's the only time I've seen him do work all week. So, which is good. Well, thank you, Mark and Darren for participating in this session. I'll hand over to Martin just for closing. But thank you very much all for attending the session. And if you haven't already received notification of training from myself over the course of the year, just drop me a line because we're having more and more courses coming up. There's we just finished the training for ClearPass, a 2-day training for ClearPass for free. And we're now going to be doing the next one coming up towards the end of the month is the UXI sensor training, then followed by switching. So if you're not receiving training notifications, please let me know. I'll hand over to you, Martin, for closing.
Thanks, Sid. Okay, everyone. Well, thank you very much for those presenters. I thought, as you would all know, you expect that I know everything, and I thought I knew everything, but I was wrong. I didn't know about those CX6000, so thanks, Darren. Didn't know they were coming. So yes, a special thanks to Mark and Darren and Aria, and a very small thank you to Sid. Thanks also to Katie for the vouchers that hopefully you've all got your Uber Eats vouchers. You may not use them today, but use them this evening. So thank you to Katie for that. And thank you all for attending. I'm pleased to see such a good response. Was getting sick of being berated by people saying you're not keeping us up to date. And I said, well, that was Sid's fault. So I'm pleased that Sid responded and we've had you all here and hopefully that was beneficial. So I just want to finalize with one small thing. I just want to reiterate what Katie said, specifically Trident, this little thing here. We are an independent reseller. We can partner with whoever we like, and we choose to partner with Aruba because we think it's the best of breed. They're the best product. The Aruba people are very good to deal with, but it's a great product at a great price. And I think I'm going to say probably 99% of Trident customers are running Aruba and they're very happy. So we're happy with Aruba. I hope that you're happy with Aruba. I hope that you're happy with this presentation. I hope you're happy with me, and I hope you're happy with life, even though we're all in lockdown. So thanks very much, and we'll see you all soon. Bye for now.